Okay, so part C of this problem asks us to find the time needed to move from equilibrium to 12 centimeters. So we can just go ahead and convert our 12 centimeters to 0.12 meters. And the equation for position given in the book is that our position is equal to our amplitude times cosine of our angular velocity times time plus phi. And if we set phi equal to negative pi halves, that will manipulate the equation such that our position can be given by our amplitude times sine of our angular velocity times time. So now what we need to do is just manipulate this equation to find what t is. So we have that our sine angular velocity times time is given by x over our position over amplitude. And then just by the laws of trig, we can take the inverse sine of both sides to clear this out. So that's going to be our angular velocity times time is equal to arc sine of x over a. And then time is given by arc sine of x over a divided by our angular velocity. Alright, so then that's going to give that our time is equal to the arc sine of our position, which we know is 0.12 meters, over our amplitude, which we were given at the start of the problem is 0.18 meters. 0.18 meters divided by our angular velocity, which we found to be 5.34 radians per second. 34 radians per second. And then we do all this fun math and we find that our time is going to be given by 41.8 degrees. Well, we don't want degrees. Excuse me. So this, the top part is going to be 41.8 degrees divided by 5.34 radians per second. So what we want to do, again, we don't want degrees, we want this to be given in radians so we can cancel this out. So, just go ahead, 41.8 degrees. We know that 1 degree is the same as 180 pi divided by 180 radians. So that's going to be over our 5.34 radians per second. So radians will cancel out here, degrees will cancel out here. And because this is a fraction below a fraction, the second is just going to come up here, and we can just do this math, which comes out to be 0.14 seconds is the time it'll take for this pom-pom to go from rest to 12 centimeters.